This video is going to talk about how to find the difference quotient for different functions. The difference quotient is right here, it's f of x plus h minus f of x all over h. It becomes very important in calculus, and so we spend a little bit of time working on it. So I'm going to do some examples of finding difference quotients for the following functions. The first function is a polynomial, f of x equals x squared plus 3x plus 2. The main thing to remember about these functions is that the x isn't the important thing. In fact, I like to think of it as f of something equals something squared plus 3 times something plus 2. And then we're going to fill in the something. So if you think of it that way, you're in better shape. Same thing up here, I like to think of the difference quotient as being f of something minus f of something all over h, and then you fill in the somethings. So we're going to go ahead and do that now. We're going to go ahead and write down this difference quotient here. F of something minus f of something all over h. And the first something is x plus h. The second something is x. And now we can go use it in our function. So our function is something squared. So our function is something squared plus 3 times something plus 2. So there's the first f of x plus h minus the same function, x something squared plus 3 times something plus 2 all over h. And then again, we're going to fill in that something. So I'm going to just take a different color. In this first one, the something is x plus h. X plus h. The second one, the something is just x. And now it's just doing some algebra to simplify this. So let's go do some algebra. I notice I have x plus h squared, so that would be x squared plus 2xh plus h squared when I multiply that out, plus 3x plus 3h plus 2. And then subtracting off x squared plus 3x plus 2. So remember, all the signs get changed. It'll be minus x squared minus 3x minus 2. Again, all of it over h. You haven't done anything with it h yet, so don't lose it. That sometimes happens. All right, so now you're just going to collect like terms. So looking up here, I notice that I have an x squared here, minus x squared here, and a positive x squared here, so they're going to cancel. I notice I have a positive 3x here and a minus 3x here, so those are going to cancel. I notice I have a positive 2 and a negative 2, so those are going to cancel. So what I'm left with is 2xh plus h squared plus 3h all over h. And one of the things I notice is every term in the numerator has an h, which means I can factor that h out. So I have 2x plus h plus 3 all over h. And then I notice, well, there's an h in the top and h in the bottom, so I can now cancel those h's. And I'm left with 2x plus h plus 3. If you're doing the difference quotient correctly, you should be able to cancel this h that's in the bottom at some point. If you didn't do it correctly, then you can't cancel it out, and that tells you you did something wrong. So this is the simplification of that. In calculus, we do something more with this, but we need to get to this step. Let's try another example. Let's try f of x equals the square root of x plus 2. So again, my difference quotient is f of something minus f of something all over h. The first something is x plus h. The second something is just an x. Then my function is the square root of something plus 2 minus the square root of something plus 2 all over h. So all I'm doing is replacing this f of x plus h with the square root of something plus 2. Then I put in what is the something, and the something in this case is x plus h. In this one, the something is just x. So now what I have is I have not too much, not too great. It doesn't look all that wonderful. It doesn't look like I can do anything with it. I have x plus h plus 2 square rooted minus square root of x plus 2 all over h, and I got to figure out what to do with that. So this goes to that concept that you saw in pre-calculus or in previous math classes where you have to multiply by the conjugate to rationalize the denominator normally, but now we're going to rationalize the numerator. So we're going to try to get rid of the radicals in the numerator by multiplying the top and bottom by the conjugate of that numerator. The conjugate of it is just x plus h plus 2 square rooted plus the square root of x plus 2 all over h. So all that happened is you took the same expression, but you changed that minus to a plus. And then it's over top of not h, but over top of the same thing again, because you can't multiply by anything different. You're basically multiplying by the number 1. So this is why you have to do this, because this expression is 1, and you can multiply anything by 1. So we're going to multiply this out. So the numerator is going to be the square root times the square root, which is just a thing inside, x plus h plus 2. Then you've got the square root of x plus h plus 2 times the square root of x plus 2. And I'm just going to go ahead and write that as the square root of x plus h plus 2 times the square root of x plus 2 and not actually multiply it out together. Then I'm going to have a minus the same thing, square root of x plus 2 times the square root of x plus h plus 2. And then my last one is going to be minus square root of x plus 2 times the square root of x plus 2 is just x plus 2. I put it in parentheses because I got to remind myself it's minus. And then the whole thing is over top of that h was in the bottom and the square root of x plus h plus 2 plus the square root of x plus 2. Again, I'm not going to multiply this out. You're going to see why in a couple minutes why I don't bother multiplying it out. Now let's go ahead and collect like terms. So the reason I didn't worry too much about these two square roots is they're exactly the same but opposite signs, so they cancel. X also cancels with x, and 2 cancels with the 2. So all that you're left with in the numerator is h. So in the numerator I have an h. In the bottom I have h times the square root of x plus h plus 2 plus the square root of x plus 2. This is why I didn't multiply the h through, because now I notice because they're in this factored form, I can cancel these 2 h's. If I had multiplied that h through, I couldn't have canceled the 2 h's. So it was important to me to not multiply it because I would have had to factor. Now I notice I'm left with 1 in the top. In the bottom, I'm left with the square root of x plus h plus 2 plus the square root of x plus 2. Again, notice if I'm doing it correctly, this h in the bottom should cancel, and notice it did in fact cancel. So this is simplified as far as it can go. And again, in calculus, we do something more with this, but right now, we're just going to stop where we are. So we haven't actually done any calculus here. This is just algebra. Let's do one more, or a few more. Let's look at this one. So again, I'm going to start off with my difference quotient. So I have f of something minus f of something all over h. The first something is x plus h. The second something is x. My first expression is 1 over something minus 6. My function also again is something 1 over something minus 6 all over h. In the first something, in the first function, the something is x plus h. In the second something, the something is x, second function. So now I have this. I'll make it just a little bit prettier, just to kind of make it look like something I can work with. So I have 1 over x plus h plus minus 6 minus 1 over x minus 6 all over h. So again, I want to simplify this, and I got to figure out how best to simplify this. The best way I can think of to simplify this is to actually, this is a complex fraction. We don't like complex fractions. We don't like having fractions within fractions. So we're going to try to make this into one fraction. The easiest way to do that is to multiply numerator and denominator by the conjugate, not the conjugate, by the lowest common denominator of the numerator and of all the denominators. So we're going to multiply the numerator and denominator by the lowest common denominator of all the denominators, which happens to just be x plus h minus 6 and x minus 6. So we're going to multiply the top by x plus h minus 6 and x minus 6. So that we can multiply by 1, we're going to do the exact same thing at the bottom. And now we can go ahead and multiply this out. So this whole expression x plus h minus 6 times x minus 6 is being multiplied by the first fraction, which means the x plus h minus 6 cancels, and you're just left with x minus 6. In the second one, same thing, you're going to multiply the 1 over x minus 6 times x plus h minus 6 times x minus 6. In this case, the x minus 6 cancels, and you're left with just x plus h minus 6. Notice I left it in parentheses because that minus sign. My denominator, nothing again will multiply out. You don't really want to multiply it all out. So I'm just going to multiply, write it down as to what I have. So I have h times x plus h minus 6 times x minus 6. Now let's simplify that numerator a bit. So what I notice is my x's are going to cancel and my 6's are going to cancel. And what I'm going to end up with is minus h in the top. H times x plus h minus 6 times x minus 6 in the bottom. Then I notice, hey, there's an h up here and an h in the bottom, so both the h's cancel. I'm left with negative 1 in the top and x plus h minus 6 times x minus 6. I wouldn't multiply out the denominator. We'll need that later in the factored form anyway, so just leave it like this. Let's look at a couple more examples. These get to be a little different, so I want to kind of show you what we do with these. Again, we have our difference quotient, the function of something minus the function of something all over h. The first something is x plus h. The second something is just x. So in this case, my function is e to the 2 times something minus the function e to the 2 times something all over h. In the first expression, the first function, my something is x plus h. In my second one, my something is just x. All right, so now what do we do with this? This looks a little bit more work. So one of the things I noticed is that this would be e to the 2x plus 2h minus e to the 2x all over h. And that doesn't look great either, but I do remember that there's a nice exponential rule that says e to the 2x plus 2h is e to the 2x times e to the 2h minus e to that 2x there over h. So that simplified that a little bit, but now I notice both these terms have an e to the 2x. So that tells me I can factor it out. And unfortunately, that's as far as this goes. There's something more we're going to talk about later when we get into doing this with calculus, but I wanted you to get to this point. We can simplify it to this. Let's also look at a trig function. So again, we've got our difference quotient, f of something minus f of something all over h. My first something is x plus h. My second something is x. I get sine of something minus sine of something, that's my functions, all over h. My first something is x plus h. My second something is x. All right. And then you go, wow, what do we do with this? So this is where those trig identities that you probably didn't care too much about and didn't think they were important actually are very important. The sign of a sum is the sign of the first times the cosine of the second plus the cosine of the first minus the sine of the second. So this becomes this minus sine of x all over h. All right, so now that we've done that, Now we have to look at what can we do with this. Now it doesn't look like a whole bunch can be done with this, but there is something more that can be done. So we're going to go ahead and look a little bit more into this, and we'll see what else we can do with this. So let's see. One of the things I noticed is I can kind of put them together. I can put the terms together a little bit and see how it goes. And kind of say, well, let's go ahead and put the sine of x terms together. So I have the sine of x, cosine of h, minus sine of x, minus cosine of x, minus sine of h, all over h. And you go, well, that doesn't do much for me. But what I notice is both these terms have a sine of x in them. So I can pull that out. So I get cosine of h minus 1, minus cosine of x, sine of h, all over h. Again, this doesn't look like there's much we can do with this, and there really isn't a whole lot we can do with it at this point. Again, later when we get into this, we'll show you how to do more with this. But I just wanted to show you that we could get to this point and what can happen at this point. The last one I want to look at is the natural log of x minus 3. So again, the difference quotient is f of something minus f of something all over h. The first something is x plus h. Second something is x. When I go to do this, my function is the natural log of something minus 3. So my function is the natural log of something minus 3 all over h. In the first function, my something is x plus h. In my second function, my something is x. And again, it doesn't look like there's much we can do with this. And you're right, there's not a whole lot we can do with this. So we're going to actually call it done at this point. And like I said, when we get into more information, we'll see what we can do to find out more about this one. And those are the different difference quotients we're going to see.